Hi, we are Capgemini astrologers. We have built a forecast engine for aviation sector to reduce their maintenance costs. We did a bit of market survey. We observed that every airline is spending a quite amount of money for maintaining their aeroplanes. So how we reduce the cost? That's where we got the idea. Why not we build a forecast engine using Predix platform and use that for planning the engine maintenance plan for the field service engineer. So using the Predix platform, we have used quite a lot of services to build a solution.
We have used Predix asset services to get aviation asset data and store it. Also, we have used Predix analytics services for forecasting the maintenance data for planned and unplanned engine removals. Also, we have also taken into consideration the security of the data and the integrity of it. Thereby, we have been using the Predix UAS services for the security purposes, and also for the data repository we are using Predix data services. And for the receiving the data continuously from the aviation sector, the sensors that are available there, we have used the Predix machine services, wherein the USGI bundles are uploaded onto the Predix machine, and which are Predix machine container, which are later then uploaded to the Predix cloud, which is accessible through a microservice.
Coming to the UI, we have used the Predix view services. Mainly, we have composed the UI with polymer components in the dashboard.
Also, we were thinking of using blockchain data integrity service. Unfortunately, as it is a paid service, we could not use it. And we are planning to use that blockchain data integrity service for checking the integrity of the data before and after analytics, because it's a crucial analytics for my aviation sector. If something goes wrong in the analytics, then the prediction outcome also will be poor, right? To improve the prediction accuracy, we wanted to make use of the data integrity service. And so let us go to the demo now.
The first part is the data integration into the cloud from the sensors. So here you are seeing the Predix machine web console. Now here you can see the USGI bundles that we have uploaded, and through HTTP river we are getting the data through a microservice, which is uploaded later onto the Postgres database in cloud.
Here is the web application we are presenting you. This application will demonstrate how you can build a training data set for building the prediction data model, and how you can apply what if analysis to predict the rates.
As explained earlier, the cloud data extraction loaders will enable the engine failure events from various sources like flights, events, and shop data to be ingested quickly and efficiently to cloud data storage for further analysis. In the events model there, we will be modeling the events and storing it in the asset services and building a training dataset in the Postgres services.
Well, we have built the training dataset. Now we will be applying the logistic regression classifier algorithm to forecast the failure event. We have identified quite a few 6 or 7 dependent variables, and the predictor variable will be the event failure code. So we will be predicting the event failure code so that the field engineer can plan for the engine maintenance. Also, we have used the analytical component to change the possible values in the alert level of the data analysis to see how it will impact the 12-month event count as well as the outcome of the forecast rate. So this is what we have done in the what if analysis.
In data visualization, we provide the dynamic dashboard, which comprises of interactive charts showcasing a variety of dynamic visualization of data as well as the summary of data.
First, we will show our data integration capability we have already shown you the predict machine web console where we have already deployed a OSDA bundle. On demand, if you are looking for uploading the data from any data source, then you can use the screen to choose what is the data that you are looking for. For example, this is some sample data because the event failure is a continuous stream event, right? So we do not miss even a single data because our prediction model is based on supervised learning method. So we will we don't want to miss any kind of data. So you can do the data loading even manually here. So once you load it, you can visualize the data, you can review the data, then you can upload this. So now let us view what is the data, what we have. Now you can see that the data that we have uploaded, we have already built the training data set. Now the new one which we have added also is available here. Now this is a good screen where we are
using one of the polymer components which is TX data table to showcase the data where we can filter the data before uploading it.
The very good feature of this particular component is that you can do any kind of filter. For example, I want to see the engine event type of only UER. So I can type only UER. So you will be able to visualize and analyze the data even in this particular screen also. So this is a good capability where the user can upload the data, review the data, as well he can visualize the complete whole training data set. Fine. Now let's see how prediction analytics. So this screen is good. We are demonstrating here. We already built the training data set. Now I have got a test data set. I am given a particular engine model, I am given a particular engine sector, I am given a particular engine features. And for these values, I want to predict what will be the possible failures. So, here is my test data set. So, this is my test data set for which I don't have the failure code. So once I pass this test data set, in fact we are using the logistic regression method to forecast the failure. So I am pressing submit where we are invoking the logistic regression API, analytic API, and then we are forecasting. So you can see that for the given ESN, the possible failures could be the oil system or the starter failure or AC fuel. So what are the predicted values you can see, and the prediction accuracy can be the logistic regression model performance also can be visible. Now what anyone can do is, supposing I am not happy with the accuracy of the logistic regression model, you can use any other statistical model. Of course, predicts gives you a lot of APIs like random forest cluster algorithm, density-based clustering assignments, and etc. Fine, Shivani, what if my prediction accuracy is not good?
Well, Uma, for that, I guess we can use the gradient boosting classifier, which will boost our prediction accuracy.
That's a good idea, and that's a good API which is from Predix platform. Also, quickly we want to show that what if analysis. So as I was saying, you can change you can check the various analytical levels, and then you can watch for what will be the forecast rate and whether it is within the 12-month rate count or not. Okay, and now I would like to show some more prediction. How I am going to use this prediction outcome for maintaining the engine management plan. So, for planned and engine management removals, we observed that there are some dependent parameters for like loss smooth value, removal limiter, fleet deterioration rate, and ECT days for a given engine. So, once you give this data, the relevant data, then we can predict, we can we can calculate the plant removal date using our analytical component, which is deployed in the predicts catalog. Okay. Now you are getting what will be the plant removal date. Now the field service engineer will be able to visualize, okay, when I am going to remove the engine, when I am going to replace the engine. After all, it's an aircraft engine. You cannot just remove immediately and you cannot repair it. So such kind of well-planned management plan is needed, and that is where we are helping you here. Okay, so in fact, sometimes the field engineer, why not I change these values like remote limiter continuously, and I would like to see the effect, So we have created one more screen for that, where the FDR value is automatically getting incremented. Now the field engineer can dynamically visualize the plan. Okay, so this is an automated event where he can change the possible values of various different parameters, and he can plan for the engine management plan. So this is one of the additional features we gave you. Also, by using the map analysis, one can visualize in which different part of the shop the different failures are happening. Finally, the dashboard of our failure events. Of course, field engineer, he wants to visualize in the last 12 months what is the most occurrence event, when it happened, and why it happened for different fleets. So you would like to analyze. So here you can visualize the data, what are the possible events for last 12 months. This chart shows the event drivers for a particular flight, and we have one more dashboard. This dashboard will give you the top 10 event counts, and if you move over here, what is the 12-month count for every cause? AGB bearing, there was 3 times it failed. ENGA, there were 5 times it failed. Our data count will be for the whole year, how many times it failed. So by providing this kind of dynamic dashboard, the field engineer will be getting an idea how the events are, how and when the events are happening. Hope you all liked the prediction journey. So hope you all will use this forecast engine to reduce the maintenance costs in the aviation sector. Thanks for giving us the opportunity to present our application. Bye. Bye.